Aloha, Rich Halverson here. This is its388al, and today I'm going to take you through the last lab 8.10 on nested functions. So let me share my screen. And on the left here, we have our lab, and on the right here, I have some notes, which you can follow along if you'd like to. I'm going to use these notes to show you what's going on here. Okay, so we have this C program. And we have a main program which calls a function here called sum. It's called sum. And this is the function that it calls. Calls this function, takes in two parameters, modifies them a little bit, and then calls this diff function. And the diff function is right here. And all the diff function does is take this parameter and subtract this parameter and return that. Okay, so anyway, that's what's going to come back here, and that's get in sum, and that gets stored in P, and then we're going to do the same thing. We're going to mess with the parameters a little bit, and then we're going to call diff again. It's going to do the same operation, subtract the first one from the second one, and then store it in Q. And then when sum's done, when that's done, sum is going to take P and add it to Q, and that's what it's going to return. So that value is what's going to come back right here. And then, of course, that's going to get added to whatever Y was into whatever X was, and that's going to, and then it's just going to return to 0. So it's kind of a dumb thing, but all right. So they have given us this, they give us this, and they give us this. And we just have to write this. Okay, so first of all, we have a variable X and a variable Y, and we're going to use these registers to store X and Y, and Z is going to be returned right here. That'll be in T2. We're going to test, for example, if we test it and we put a 5 in T0 for X and a 10 in T1 for Y, then it's going to do a bunch of calculations, go through all this, and it's going to end up with a T2 is going to end up with 11, according to how this formula is applied. It's not really important for us to understand what's going on here. We just need to mechanically convert this C program into the MIPS program, following the conventions of passing the arguments, and then passing the arguments, and then getting the arguments, returning the value, returning it, and so on. If we look at the code that they give us, we see that we've got a main program here. Okay, I tell you what I'm going to do. I'm going to copy this out, make it easier, and I'm going to use some kind of sort of notepad plus I'm going to use. Let me open up a new one here. Here's Notepad++, blank. All right, so let's start by copying this out first, and so we can see this better. Copy, paste. Okay, here it is. Okay, so we have this main program. It's in different places. The main program is here, and then this is the sum function procedure. That's what we're going to write, and then here's the diff function that they give us. And of course, they say don't modify this and don't modify this, because you need that to make sure that when we write this, it executes properly and so on. And the example turns out like the example says. All right, so let's okay, so I'm going to put this over here, and I'm just going to start writing this. Okay, so here I explain what we're doing. This is a function. Okay, so we have a main program which calls this, okay, and they give us the code for the main program, and they give us the code for the diff function, and we have to write the code for the sum function. So the main program calls a sum function. It passes x as the first argument and passes y as a second argument. And we're going to use t0 here to store the x and t1 to store y, and t2 is going to be used to store t. It turns out that we're going to use t3 and t4 also when we are doing the diff function. You notice the diff function here uses t4. Anyway, so let's get started here. So we see in their code, first they push t0 onto the stack, then they push t1 onto the stack, then they push a spot to give us the value. Let's look at that here. First we push t0 onto the stack. Okay, we make a spot for it. We decrement the stack grows down. So we're gonna make a spot for it, 4 bytes per integer, and then we're gonna store t0 at that spot. And then we're gonna make another spot, t1, and we're gonna store t1 there. So now we've stored we've pushed t0, we pushed x onto the stack and we pushed y onto the stack. And then we're just going to increment the stack pointer by 4, or make another spot on the stack pointer on the stack for the return value. And then we're going to call the sum function. Okay, so we've loaded the first argument first and the second argument second, and then we've made the spot, and then we call sum. Okay, so this is what we just saw over there on the left. We push t0, then we push t1, and then we open up a spot for the return value, and then we call sum. And we use the JAL function. Now, the JAL instruction. So what does the JAL instruction do? Well, first of all, of course, it jumps to the beginning of the sum code. That's what this is. JAL jumps to the beginning of the sum code, which over here is going to be here. It's going to jump to here. But before it does so, it stores the program counter into the RA register. Okay, now the RA register has got, okay, so we're down here and we're that's what the JAL instruction does. Okay, so it stores the program counter, which is currently pointing to this location right here. This is where the program counter is pointing, because it always points to one after the instruction that's currently being executed. This instruction is being executed. So the program counter is the address of this instruction. And so the the JAL instruction, the last thing it does is it sticks the value of the program counter into this RA register. It stands for return address. And that's so when the sum function is done, it knows to go back to here. You know, when this is all done, it's going to continue execution here. So it's got to remember that spot. So that's what that's for. So when the sum, okay, so when the return address, okay, so that's that. When the sum function is done, we also we pop off the return value. And then we also adjust the stack to account for the 2 arguments that we pushed onto the stack. Okay, so now before we start coding the sum function, let's take a look at the diff function to see what that is expecting. Okay, so that we see the diff function expects to pull its parameters from stack pointer offsets 12 and 8. So this here is a picture of what the stack looks like. And we aren't using all of these, but a stack frame, it can contain all these registers. And you recall the stack grows down. So the first thing was we push the first argument on, then we push the second argument, blah, blah, blah. And then we push the return value, or then we push a spot. We aren't pushing anything. We're actually just making a spot for the return value. That's the next position in the stack. And then if we want to, if we need to, we're gonna we can save registers. When we call a subprogram or when we call a function, that function may want to use some of the registers. And right now we're using right now we're using the return address register. So in here, before we call diff, this is going to be up in the sum function. This is going to be over here in the sum function. Before we actually call diff, we're going to load the first argument, and that's going to end up being at 12, offset of 12. We're going to load the second argument. That's going to be at offset 8. At offset 4 is going to be the return argument, the return value. And then at the 0th position of the stack, we're going to save this return address. Why? Because the diff function is called by a function which was called. And so the return address is got to be saved, because the return address contains where the sum function returns to, back up here. And we're going to need that register because we're going to call diff, and then we got to. All right, so notice also that that we're letting the diff function use T0 and T1. Okay, if we wanted to preserve T0 and T1, then we would have pushed them onto the stack, but we're not going to. Okay, so T0 and yeah, so let's see the diff function. Oh yeah, so the diff function is we're loading the operands into T0 and T1, and then we're storing the result, the subtraction, the result of the subtraction, which is the diff here. The diff just subtracts the two T1 from T0 from T1 and stores the result in T4. We're skipping T2 and T3 because those are reserved for the sum function. So, and this is all possible. It sounds like, well, gee, it's, what if the sum function was not using the T0 and T1? How does the diff function know if the sum function is using T1 and T2 and T3? Well, the compiler knows. So the compiler has looked at everything, and the compiler looks at overall how it's going to allocate variables to registers and so on to make sure that nothing is destroyed that needs to be saved, and that we're conserving as much as possible. We don't want to be saving out registers and then popping them back out again when we don't really need to. So so for the sum function, we now see that first we grab the parameters off the stack, we calculate the result, put the resulting value back back onto the stack, and that's what the main program is expecting. All right, so we're gonna be allocating for variables m and n. In sum, we're going to be using T0 and T1, and then for variables p and q, that would be for m and n in sum. Those are the parameters; those are passed from here, so it's x and y. And then for p and q, we're going to use T2 and T3 for that. And then we'll let diff use T4 as a temporary variable because it's going to pull out. It has to have some place to put the result of the subtraction. So anyway, let's start typing some code here. Let's see. Before we get started, I'm gonna straighten out these tabs because I'm going to want to just paste this back in. So back. that one. Let me fix this one. And let's line these up. Back tab, back tab, tab. Okay, there we go. So now they're all lined up. Okay, so let's start typing our code. First of all, we're going to pop off the arguments from the stack and store them into registers. We're going to store the first parameter into T0 and the second parameter into T1. And these are, this is going to be an offset 8 from the stack pointer. This is an offset 4 from the stack pointer. And offset 0 from the stack pointer is where we store the result. Pass back to the main program. So let's just load word. Let's load into T0 offset of 8 from the stack pointer. And this is gonna pop, let's comment this, pop M into T0. Okay, and then we're gonna let's load word into T1, 4 from the top of the stack. And this is popping N into T1. Okay. And then we're actually right here where we've, wonder what happened here. Interesting. Okay. T1. Okay, so we've got M in T0 and N in T1. And when we set up for the diff, it's going to be we pass N plus 1 as the first argument and M minus 1 as the second argument. N now is in T0. No, M is in T0, N is in T1. Okay. M is in T0, N is in T1, and we want to take T1, add 1 to it, have that be the first parameter for this first argument. And then we're going to subtract from M 1, and that'll be the second argument into this diff function. So that's why we're going, this has got N in it. And so we're going to take, we're going to subtract 1 from that, ADDI, from T0, that's the T1, that's where N is. T1, subtract, and we're going to store back into T0, into T1. I'm just going to copy this here. Okay, so we subtract, this should be, what's N plus 1, M minus 1. Okay, so it is N plus 1. So we add 1 to N and store that back into N. And then we're going to push, we're going to make a place for it. We're going to push it onto the stack. So we're going to, first we got to make a spot for it on the stack. We're going to decrement, we're going to make a spot for it on the stack. Remember, stack rows down, so that's why we're subtracting. And then we're going to store the T1 value, the computed N, this first argument, we're going to store that into T1. Well, we're going to store that into the stocks in the stack. We just made a spot for it, and we're going to store that into the stack. That's the first argument. This is the first argument that's going to be sent to the diff function. And then we're going to do the same thing for the second argument for M. We're going to, first of all, we're going to subtract 1 from M. You recall this is the first argument first parameter passed into sum. And so that's why it's T0. Okay. Keep that straight. And then we're going to make a spot for that argument to be passed on to, we're going to pop that or push that onto the stack. So now the second argument, which is n-1, is stored on the stack. The first argument, first we stored n+1 onto the stack, then we stored n-1 onto the stack, and then we're going to have to make a spot for the return value. Remember, we're getting ready to call diff, so that's a result, a spot for the return value. And then since this is a function calling a function, since this is the sum function calling the diff function, we need to save the return address back to the main program. So this is the sum function's return address. This is the RA contains the return address when sum is all done and it jumps back to the main program. Okay, that address is being stored in RA. So we're going to need RA because we're going to call another function and we need the return address back into sum. Okay, that might be confusing, but anyway, so we push that in. So we've made a spot for RA. No, we got to make a spot for RA. And then we're going to push RA onto the stack to save it. Okay, so we're pushing the return address. We're actually going to put something here. We aren't going to bother with any of these, but we are going to push the return address on. Okay, so we've done that. Now we're ready to call diff. So let's go ahead and call diff. Okay, now we've called diff. And diff is going to do its thing. Diff is going to grab off. You see this one was pushed. Then this was pushed. Then we had a spot for the RA, and then this was pushed. So the arguments are going to be this first one, n+1 is going to be 12. Back up from the stack. This is going to be 8, and then the return value is going to go into 4. That's what it's putting the return value in there, and the 0th position of the stack is this pushed value there. So and then when diff is all done, we jump to the return address. So this is going to jump back to this spot right here. Okay, so let's go back to that spot. And so we are back from diff, and the return value is first we have to restore. First we have to restore RA. Remember, RA is there first. RA was the last thing we pushed onto the stack. This was the last thing we pushed onto the stack. And so that's the first thing we pop off the stack. And let's decrement the stack pointer. And then we're going to pop off the return value. This is the value that we've been looking for from diff. That's the return value. We're going to put that in T2. Okay, the return value is going to be put in T2. That's where we're going to store P. That's this thing here. We're doing this right here. We're storing the value from diff into here. And then we need to so we popped off the return value into T2. That's where P is. Then we got to decrement the stack again. And then we need to sort of, we can say, flush the stack. We're going to get rid of the second argument that we pushed down there, and then the first argument that we pushed down there. So that basically gets rid of this that was pushed down to the stack and this that was pushed down to the stack. We don't need them anymore. So we just have to put the stack back where it was before we even started the call. Before we started the call, setting up the call for the first diff. Okay, so this gets rid of the second argument. And this gets rid of the first argument. So now the stack is back where it was before we started the first call. Okay, so let's do the second call. Well, T0 and T1 no longer contain M and N. We used T0 to compute this, and we used T1 to compute this. And so now we're back where we started. So let's start again by we start by popping off the original arguments off the stack. They're still there. So we're going to pop off the original arguments, just like we're actually going to do all of this exactly again. Okay, except for we're going to mess around a little bit because here we're passing n+1 as the first argument and n-1 as the second argument. And the second time we call diff, we're going to be calling n+1 as the first argument and n-1 as the second argument. And that's going to get stored into Q. Okay, that's where we are right here. So let's go ahead and we're going to get ready for the second. I'm going to put a comment here. Prepare a second diff call. I'm going to put up here start with first diff call. Okay, so now we're going to prepare the second diff call. First thing we're going to do is pop these things off the stack just like before. And just like before, and then we're gonna for T0, that's gonna be M plus, we're gonna add 1 to it. We're preparing the two arguments, and this time M goes first and N goes second, and the first one we're adding 1 to M to that to make that the first argument, and the second argument we're subtracting 1 from N to make the second argument. So let's do that. Let's just use T0, and we're going to increment. We're going to create n+1 here. We're going to make a place on the stack to pass that argument, and then we're actually going to store that m+1 argument onto the stack. And then we're going to take T1, which contains n, and we're going to decrement that because this is the second argument, n-1. And let's make another spot on the stack for it, just like before. And then let's put that second argument on the stack. And then let's create a place for the return value. And then let's we need to store the return address again, just like we did last time. Since it's a function calling a function, we need to store let's make a place for the return to push the old return address, the sum's return address. We're in sum here, we're creating this thing. So we're going to push that. This is the address to return back to the main program. We're going to push that on stack, save it. And then we're going to call diff again. Oops. Call diff. And when we're done, we get to we gotta restore RA. Okay, it's back now. It's sitting on the stack. But first thing we got to do is restore RA, and let's return address for sum and decrement the stack. And then we're gonna have to let's pop the value that diff returned, and that is Q. And we're going to store that in T3. So now remember, T2 has P, T3 has Q. And let's decrement the stack one more time, because we've gotten rid of the we popped off the return value, decrement the stack, and then we're going to decrement the stack 2 more times to flush out the arguments when we called diff. Okay, those were the arguments that we passed in. So we're going to flush the stack, and now the stack is back where it should be, where it started from here. It's back to where we are now able to compute the final result for sum. We're actually able now to do this part where we compute P and Q. This is going to be, we might as well use T2. We're going to take T2 and add T3 and store that back into T2, and then we're going to push T2 back onto the stack where the main program is expecting the return value, which is going to be right at the top of the stack. So we are down here. So we've got P in T2 and Q in T3. So let's add Q to P. Let's take Q, add it to P, and store that back in P. And then let's push, this should be S, should be SW, not AW. Let's push this, the result, the sum, the result of this calculation onto the stack, right where it's expecting it, right where the main program is expecting it. And then let's jump back to the correct spot in the main program, which is in the RA instruction. When we called sum, this, you remember, this instruction puts this address into the return address, into RA. This instruction puts whatever the address of this is into RA. So that way, when we're done with sum, we jump to the memory location, the program memory location that's being stored in RA. We jump to that, and that jumps us back to here. So we're able to continue on, and presumably, if our sum code is correct, then everything is correct. So how do we test it? Well, let's test it by just, I'm going to copy this, oops, what am I going to do here? I'm going to do Control A, and Control C, copy it, and I'm going to paste it into, let's see, I'm going to go back to, this is the MIPS simulator here. I'm going to go to this MIPS simulator. I'm going to paste the code into here. There's all the code. There's diff. There's our sum function that we just wrote. And then this is the main program, which calls the sum function. Let's assemble this. No, what's this? Oh, it doesn't like the arrows, does it? Line 52. Okay, it doesn't like the arrows. Let me get rid of that arrow. Oh. Oh, no, it's not the arrow. It's the $sign in front of the SP. There we go. It's got to be a $sign right there. All right, let's try it again. Another one here, $sign. Again, 78. I must have done a big copy paste here. Put a $sign in front of the SP, and there must be another one here at 81, $sign. Okay, now let's assemble. Okay, it assembled okay. By the way, there's the bits, pretty long program. Let's go ahead and I'm gonna more options. I'm gonna set it to instant just because I want instant gratification. Enter the simulation and run it, and boom. Oh, I had to I didn't preload the T0 and T1. We have to preload T0 and T1. I did not do that, so let's do that. T0, exit the simulation. T0 was 5 and 10. 5 and 10. 5, and 10. Now let's get instant gratification. Assemble, enter the simulation, instant, run. 5, 10, 11. Is that right? 5, 10, 11. Looks like it's right. You might want to start again and not do instant and do fast and actually click through it. And you can see how many times, see how it goes. It executes, calls sum, and now it's down here executing sum. And then it gets ready to call diff right here. And jumps into diff, executes diff, goes back to the return address, which is back into sum, which is right after the call to diff. Calls diff again. Right after it loads up the arguments, you see they're loading them up in the stack here. Return address here. This is the stack, it's growing down. And executes diff again, comes back right after diff. Decrements this, pops the values off the stack. We just see the stack pointer increasing. And we come back and we're done. We're done with sum. We add 1 to there and it becomes 11, and then we're done. All right, let's see. So that should take you through the last lab, and hope this helps. Thanks for watching.